For centuries, humans have been able to preserve meat without refrigeration. Have you ever wondered why companies still use the same techniques to package hot dogs as they once did? Well, we have the answer. It's nitrite. The elements that are involved are two oxygen atoms and one nitrogen atom, giving it a negative charge. Now, let's discuss the history of this molecule that has changed civilization as we know today. The Greeks were one of the first people recorded to use salt-containing nitrites in order to preserve their precious meats. Though they did not fully understand this process, this was a major breakthrough for the evolution of mankind since 850 BC. And also, they had other things to worry about, like wars and, volcanoes. Oh no! Now, with the advancement of chemistry and the technology associated with chemistry, such as chromatography, NMR spectroscopy, and spectrophotometers, scientists are now able to pinpoint some of the benefits of the use of nitrite in the preservation of meat. But why are we interested in this subject? To understand why nitrite is so useful in meat products, we first have to understand the root of it all. Botulism is a problem. More specifically, Clostridium botulinum is a host cell that injects a powerful neurotoxin. This toxin contained in reproductive spores of the bacterium causes paralysis by inhibiting the release of a neurotransmitter called acetylcholine. This neurotransmitter is responsible for the communication between motor neurons and muscle cells. Bacterial spores are one method of reproduction that microorganisms can do. Spores are similar to a chicken egg in the fact that they both have a hard outer shell and all the contents of life are found inside an embryo. The only difference is that the environment dictates when the new bacteria hatches and not the other way around. Spores need a warm environment, a protein source, an oxygen-free environment also known as anaerobic, and moisture. Sound familiar? Meat, not treated with nitrite, is susceptible to bacterial growth at a very rapid rate. This can be very harmful to humans. Yuck! However, the presence of nitrite makes meat a very inhospitable environment for the spores to grow. By lowering the concentration of these spores, the toxicity also goes down. Now, let's show you the chemistry behind it all. Nitrite, being negatively charged, has resonance that contribute to its nucleophilic tendencies. Because of the lone pair electrons, nitrite can act as a Lewis base, donating a pair of electrons from either the nitrogen or oxygen atoms. So what does this have anything to do with meat, you may ask? Meat is comprised entirely of molecules that contain hydrogen atoms. With a neutral pH of around 7, it's the perfect breeding ground for these spores. However, the nitrogen atoms are susceptible to nitrite, being a nucleophile, attacking and forming a different compound called nitrous acid, causing a drop to the pH in the meat. Every decrease in the pH of the meat by 1 increment causes the concentration of the spores to subside by a factor of 2. But not so fast! Too much nitrite will make the meat too acidic. That's why the FDA only allows a max of 500 parts per million of nitrite in meats. This causes a dilemma, for it's a balancing act between human health and the stoppage of bacterial growth in the meats. There are 3 main reasons why we now use nitrites. 1 is to stop the growth of botulism, 2, enhance the red color, and 3, enhance the flavor of the meats. Let's talk about the color now. Myoglobin is responsible for the red coloration that you see when you buy raw meat. Specifically, it's a heme group in the center of the molecule that contains an iron atom. When the iron bonds with the oxygen, a red pigmentation is present. When nitrite is contained in the presence of meat, an enzyme called nitrite reductase converts nitrite into nitric oxide. This can then be bonded onto the iron, replacing the oxygen and forming an even more stable bond, making the desirable cherry red color of raw meat to last longer. Last but not least, let's talk about the effect that nitrite has on the taste of meat. Nitrite, having antioxidant properties, allows it to react with certain molecules, preventing other reducing agents, typically causing rancid flavors, to react with the meat. So, what have we learned today? Well, humans have been eating meat since the dawn of time. Because it is a favorable food source, we are more susceptible to illnesses than other animals like cows. By including nitrite into food supplies, we are able to live a healthier lifestyle by eating meat without the fear of contracting a foodborne illness. So, next time you go to the store, go to the meat section and think about how long your market can store the meat without it going bad if there wasn't any nitrite.
Thank you for watching.